Hello there, pre-algebra class. I hope you're having a good day and an encouraging one. We're going to talk about scatterplots today. So just please watch from the beginning to the end. I have a couple things that I want to say to you, and just make sure that you stay with me, and we will learn some things here. All right, so the scatter plot is going to compare a couple of different types of numbers. And sometimes there are relationships between these numbers. I want to just talk for a brief minute about some possible comparisons that you might see and what you would think would make sense as far as what you would expect their relationship to be like. So for example, if you think about what year it is and compare that to the value of your car, you might buy that car and it might be worth a whole lot of money, and then every year it gets to be worth less and less and less and less. You would say that that would have a negative relationship. If you're thinking about somebody's height versus their shoe size, if we think about that and you took a whole group of people and you talked to them and you found out how tall they were versus their shoe size, and you did from kids all the way up to adults, you would kind of expect that the taller a person was, the bigger their shoe size would be. So that would be a positive relationship where the number is going up. Then there's other comparisons where the numbers really have nothing to do with each other, such as hair color and height. You might say, okay, I'm going to ask all people what their hair color is and then how tall they are, but you would expect that there really wouldn't be any kind of relationship in that whatsoever. We're talking about scatter plots today, so what you would see, you would see some dots, and you would take the graph and the labels and figure out what kind of a relationship those things would have. So here are those three scenarios that I talked about. As someone gets taller, for the most part, you see that the shoe size would go up. Not 100% of the time. This person was a little shorter, but just happened to have feet that were larger. And this person was taller, but this person was taller and his shoe size was not near the shoe size for this one. So you do have, little renegade points, but you have a general trend going on, and that's really the essence of what scatter plots are. Now, rather than just leave them as theoretical, I did look up some things on the internet I'm just going to share with you. So none of these graphs or anything are my own. They just happen to be what we're looking at. Oh, look, there's river otters. That's there for a little bit in a minute. So let's take a look at some of these other. I did go on to a place where there was tons and tons of data, so I wanted to show you some real life scatter plots. Okay, this particular one is comparing the amount of lead in the river, in the Spokane River, versus the amount of zinc. And when they plotted those, they found out that the number was going up in comparison to the other numbers, so that would be a positive relationship. Another thing that they did is they looked at the height of a sunflower as the time and days went off, and what they found is that the flower was getting bigger and bigger and bigger over time, which makes sense. So this scatter plot has actual data in it, would be showing a positive relationship, at least to the point where the sunflower reached its maximum height. Here's another one where when you look at this data, this is interesting, the depth of the river versus how fast the river is going. So what you find is that as the river got deeper, the speed of the river got slower and slower, so this is an example of a negative relationship. Notice that there's this line drawn in here. In our study today and what we're doing in this section, we're not going to actually draw those lines in, but drawing the lines will come into your math when you get up the math levels a little bit. So this line, sometimes you'll draw a line through these. It is called a trend line, so there you're a little bit ahead, that sometimes gets drawn into this data. All right, here's another one. that is comparing a person's body weight to their brain weight. So in general, the heavier a person is, the heavier their brain will be also, because everything's proportional for the most part. We do see that it's not an exact straight line, but you've got points all over the place for that. And then also this one compared the width and the length of these specific types of clams in the Puget Sound. And we find that these points are scattered all over the place. It's real life data, so it doesn't have to make a straight line exactly, but you have a trend going on. So you have a positive relationship if it's going up to the right, a negative relationship if it's going down to the right, and if there's no relationship at all, you'll just have dots kind of all over the place. All right, so what about this river otter? I wanted us to be able to go through the process of making a scatter plot. So I just spent a whole lot of time looking for data. And I thought, okay, we need something positive and fun. So I wanted to find the data of populations for river otters. Well, I looked and looked and couldn't find any data charts for that. So somebody really ought to do a study of that, because river otters are just plain cute. I did read a little bit that their populations in different states are different. Somewhere they're plentiful and somewhere they're not. And then I remembered a long time ago hearing about the black-footed ferret. Isn't he awful cute? And I know for a fact, and I read an article or two on the black-footed ferret and found that for a while they thought they were extinct, and then they found this really tiny little population, and what they did is they began to nurse them back to health, and as far as their population, and the population grew and grew and grew until it's about 1,400 that are out living in the wild. And that's really cool that something that was thought to be extinct was actually taken and captive breeded into the point where it could be released. But once again, I didn't find a year by year data on that. But I figured we need to have something cute and positive at this point. So there's the pictures, aren't they adorable? And we're going to think about a fictional creature. And I made up my fictional creature. I don't have a picture of him, but my fictional creature I decided to call the cuddle critter, just because I don't have any specific data, and I had spent way too much time looking for the data. And so we have this cuddle critter population. We're going to think of it as being kind of like the Blackfoot, but they found some, and then they began captive breeding, and then the population began to get healthier and healthier. So we want to take a look at these populations and make a scatter plot. My daughter is pointing to our dog now. He's a cuddle critter. He's awful cute, but I don't have a way to put his picture up right now. So we'll see if we can get a picture up of the fluff at some point. So here we go. And we're going to make a scatter plot. So you need to, of course, put in your labels. So we're going to make this a year versus cuddle critter population graph. This will be hard to turn sideways, but let me just do this. Oh, I know what I can do. You can turn your paper and draw it sideways, and I'm asking right now, because we're taking the time to actually do this, I'm asking for you to take this and I want you to make yourself a graph. Okay, so please make yourself a graph. Do it by hand. You have the advantage that you can just write some things out, but I have the advantage that I can do what you just saw me doing, and I can drag and cut and paste and all those things. Now, yes, there are programs to do this, but I would rather you have a little bit more experience. If you do something hands-on, it does help you to understand exactly what's happening. So I have these axes now. The year is on the x-axis, and we've got the cuddle critter population on the y-axis. So if we notice here, our x-axis is going by ones. We don't want to start back in 0, so I'm just going to put a couple little lines here to show that we skipped a few to start. But then you want to go, once you get started on a first number, you want to go by nice, even increments. So in other words, you want each gap to be the same to represent the same amount of time or the same amount of whatever it is. So I'm going along and I'm making my marks as careful as I can. I want to make sure I've got enough space. So 2006, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So these are marked out pretty close to being nice even marks. And so I'm just going to write the end of the year, 06, 07, 08, and on and on and on. 09, 2010, 2011, 2012, 2013, 2014, 15, 16, 17, 18, 19, and 2020. And we'll take a look at this cuddle creature population. We could skip a few, but then we'd miss our 15. So we're going to have to go by some kind of an increment that is going to make sense for us, because we have to end up around 6,300. So I think if we go by 500s, we'd be okay. If we go by 500s, we'd need to have about, I believe we'd have to have about 13 of them, but let's just go through. We've got, I'm going to put a bunch of lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if we go by 500s, we've got 500. We have 1,000. We have 1,500. We have 2,000. We have 2,500. We have 3,000. We have 4,000 right here and 5,000 right here. So here's 4,000. Here's 5,000. Here's 6,000. And this one is 6,500. So we can fill in these other numbers here so that you have as many filled in. And you know that since you're going by nice, even increments, that you're going to see things spread out properly. So if I chose to go by 500 along here, each one of those little dashes is 500. These numbers, you can't just put in 15 and 27 and 32 because it's not going to really show what you need to show. So we need to make sure we're going by nice, even increments on that. I need to get a bigger dot here. All right, I want to put in some points here. So in 2006, there were 15 of them. That's a really, really, really small number, almost down to this mark right here. In 2007, there were 27, just a hair higher, but so close that you can't see. 2008, 32, just a hair higher. I probably have that too high even. Then it went down to 10. 2009, there must have been a problem. And then 2010 back up to 23, so we're kind of down there. 2011 all the way up to 52, and then up to 112. We're still not anywhere near 500, but we're kind of inching up just a little bit. 2013, 385. Okay, finally we're starting to get off this bottom line here. We're still under the 500 mark. 2014, 650. Okay, all right, that's over 500, so that's about there. 2015, 730. Well, that's more than this, but not quite up to the 1,000 yet. 2016, once again, a little bit higher, not quite up to the 1,000. 2017, 1,200. Yeah, we finally got past that 1,000 mark. 2018, we have 1,800, so that's almost up to the 2,000 mark. That's good. 2019, we have 3,200. All of a sudden, they're getting very healthy. And in 2020, we have a situation where you have 6,300 of them, so all the way up to here. Okay, this population has taken off. But what we see here is that you've got, in general, it's going up. Now, this one's a special one where it's not just a linear getting higher and higher in population, but it's actually really curving up like that. And it's important to understand those kind of graphs too. But we can see that there is some kind of a positive correlation going on, because in general, the numbers going up. Right now, we only have this one renegade. So you'd be able to draw kind of a straight line through. So we have a positive correlation happening, or a positive relationship, because as the years are going on, you've got more and more of these cuddle creatures happening. And we could draw a trend line in here with just one extra point up there. But we have a positive relationship. Negative relationship will be heading downward. And dots just all over the place with no pattern would be no relationship. So kind of picture in your mind what the cutest, cuddliest little thing is that you could possibly think of, and make that a smile thing for your today. I'm going to go back here to the black-footed ferrets that are just adorable, and think about them growing in population and getting stronger and stronger. And so we just have that, and there we go. Aren't they cute? And so they're getting healthier, and there's plenty of them now, right now, so that they're not as strictly endangered. Same with our cuddle creatures. And so I hope that that at least brought a smile to your face today, and that you learned a little bit about scatterplots. And I'm going to end this for today, and I hope that you have a wonderful and blessed day, and I miss you guys a whole lot. Bye.